In the previous graph, all the three variables were binary variables, taking two possible values, 1 or 0. But what if one or more of the variables have more than two categories? Consider the same castle model, but with the difference that the variable education can take three different values. 0 if the person has a high school diploma, 1 if the person has a college degree, and 2 if the person has a master's degree. The variables income and happiness remain the same. The joint probability distribution will be factorized in the same way, but now the conditional probability tables for each of the three variables will change. The conditional probability table for education now has three columns, given that education can take three different values, and as before, just one row, because education does not have any parent, and thus no variables in the conditioning set. As before, the probabilities expressed in the row need to sum to 1. For this case, we just need to define two values for the probabilities P and Q, and the third one will be immediately determined as 1 minus P minus Q. Let's instantiate the probabilities with the following values. In the conditional probability table for income, income is a binary variable, and thus the table has two columns. But now, education, the only variable in the conditioning set of income, has three categories, and thus the table has three rows, one for each value that education can take. We instantiate the table with the next values and check that each of the three rows sum to 1. Finally, consider the conditional probability table for the variable happiness. Happiness is a binary variable, and thus the table has two columns, one for each value of the variable. Now, to determine the number of rows, we have to consider all the possible combinations of values for the parent variables, education and income. As mentioned before, the number of rows is determined by the number of possible combinations, and this is obtained by multiplying the number of categories of each parent variable. For this case, we multiply the number of categories of education, which is 3, times the number of categories of income, which is 2. 3 times 2 equals 6 rows. As the number of variables in the conditioning set and the number of categories for each variable increases, it becomes more challenging to fill up the rows expressing the possible combinations. An easy rule to enumerate the combinations in an orderly fashion is to first choose any of the parent variables and divide the number of rows by the number of categories of the parent variable we choose. For example, if we choose education, which has 3 categories, we divide the 6 rows by the 3 categories, which equals 2. And to fill up the rows, we repeat 2 times each category of the variable education, as so. Next, we choose another variable in the parent set and divide the number of repetitions for each category we obtained in the previous step by the number of categories for the new variable. In this case, our next variable is income. It has 2 categories, and the number of repetitions assigned to each category of educations in the previous step was 2. So, 2 repetitions divided by 2 categories equals 1. This implies that we must repeat 1 time each category for the variable income and do it again until we fill all the rows. If we find more variables in the parent set, we repeat this process for each of the variables in the parent set until we fill up all the possible combinations of values for the parent variable. Finally, let's instantiate the model by adding probabilities for each entry, recalling that each row must sum to 1.